This is something that I've been thinking about for about a year, and of course, I think about how to make websites faster. And the one piece of it is, there's the whole thing on mobile about mobile web versus native, and whether you're thinking about that debate, or if we want to put the slides up anytime, that's fine with me, or even on desktop. Network is a big part of the issue. And so I've just been thinking about ways that we could try to get websites, web apps, to start as if they were native and get that network piece out of the way and even some of the other pieces. And so I want to talk about that today, and I call this whole thing pre-browsing. Okay, so especially this is painful if you're under bad network conditions, or even worse, if you have to connect through one of these things with your mobile device. Because when that happens, especially if you have a lot of weight on your site, you're going to end up with this blank white screen, and it's going to make users upset. I don't know if we can fix the resolution there. It's not going to be terrible, but it's not going to be great. This is a 4:3 talk. We're going to leave them puzzled about what's going on. Now, just a funny anecdote, because I like funny anecdotes. This site was CNN.com that I got a screenshot for. And so I was thinking, does anyone here work for CNN.com? Does anyone here work for CNN.com and not want to raise their hand? And I thought, okay, well, I want to capture a blank white screen screenshot. What website should I use? And I think, okay, well, I'll use CNN.com. But I think that's fine. I'm going to have to do it kind of quick to capture it before it actually loads. And so I did CNN.com, and actually I fat-fingered it and fumbled, and it was still blank white. So it wasn't really a challenge at all. There are lots of websites out there that have this blank white experience. So what we really want is we would love to have a browser that kind of does things ahead of time. Kind of like Corporal O'Reilly from MASH. And again, maybe I'm dating myself as the oldest Velocity co-chair. But his nickname was Radar, because he always was able to anticipate what was going to happen next and to be prepared for it. And so that's what we want in this concept of what I'm calling pre-browsing. We want the browser to get what it needs before it actually needs it, right? And then things are going to be much faster. Now, I just want to mention, this is a word I made up, pre-browsing, and I own the domain. So we're going to put a TM on it. Now, you might say, okay, well, this sounds good, but isn't this what the cache is for? And I'm like, yes, seriously, this is what the cache is for. And that's why I've been complaining about caching for years and years and years. But I'll give the cache a break, give browsers a break there. There are lots of scenarios under which, even if you had stuff in the cache, if you had a good performing cache, it's not going to make a difference. This might be the first time you visited a site, right? So that's not going to help. If you've never been to the site before, the cache isn't going to help you out there. You might have been to the site before, but the resources, the scripts and images and style sheets from the site have been cleared. You cleared it yourself. Your antivirus software cleared the cache, or maybe it got purged. You're watching a lot of video. Or you might have the stuff in the cache, but the website only put a one-day cache header on it, so the resources are expired. You're going to have to do network traffic. And on mobile, even though you might get a 304, tiny 304 response, on mobile, the latency of doing that check for 80 HTTP requests is going to be painful. Or the site might have modified. You might have the resources in the cache from the version of the site from yesterday, but today they pushed out a new version, right? So the stuff in the cache isn't going to help. So even if we had a really, really great, awesome cache, it's still not going to help under a lot of situations. So I think we should think about this pre-browsing stuff. Now I'm going to start talking about it, and as I talk about it, let's just keep in mind that there are some pluses and minuses, some pros and cons, and let's just try to get a feel for what that is going to be like. So some of these pre-browsing techniques risk a lot of false positives, some don't. Sometimes the risk of these false positives is high, it's very costly. Sometimes the cost isn't that bad. Browsers do some of this pre-browsing, right? They're responsible for it and they'll take care of it for you. Some of it developers have to do. So if you think I'm talking about you out there, I am. You are one of the targets for the points, the takeaways of this talk. So, just the facts, what am I going to talk about today? Can you see the background image? I think it's too dark. It's a fax machine. Pay attention to the background images. Get it? Just the facts. That's right. The people who were laughing, you had it wrong. I want the groan. I want the groan. That's what I'm looking for. This is what I'm going to talk about today, these 7 things. And so I thought about how could I talk about these. I could talk about who's responsible for making sure these things get done. But I think this is a better way to talk about it is chronologically. For me, that just flows better. So the preloader is something that happens on the current page that you're loading, right? I'm loading a page, and the preloader in the browser is going to be working, and it's going to do some preloading, hence the name. On the previous page, before I got to the current page, the previous page, if the developer was thinking about it, could have contained some of these link rels, right? And that could have gotten stuff into the browser before the browser needed it to get this pre-browsing thing accomplished. And then there's this transition between the previous page and the current page. And during that time is an opportunity for the browser to get a foothold and do some pre-browsing techniques. So let's look at it from that perspective. We'll talk about previous, transition, current. In the previous context, you have to remember we're on the previous page to where the user is ultimately going to be. So we don't really know with a high certainty what the user is going to do next, or not necessarily. So there's a higher risk of false positives and being wasteful with bandwidth that might cost money if you're on a metered plan. With CPU, you might be doing things in the background that are competing with the user's activity on the current page. So there is risk. But there are scenarios that we could have high confidence in. What are some of those scenarios? You can think of them search, obviously. If I type in Adventure Time, there's a very high likelihood I'm going to click on that Cartoon Network website. If I'm on a login page, it's very likely that I'm going to go to the page after login, my home page or whatever it is. And some of that stuff could have been prefetched or pre-downloaded. And if I'm on a multi-page, a paginated page, shopping or an article, it's very likely I'm going to go from this page to the next page. So there are some scenarios in which we could have some high confidence. So in these high confidence scenarios, what could we actually do? Well, as developers, we could put this link rel DNS prefetch into our pages, right? This is what it looks like. In the href, you can put / domain name. You can put a full URL if that's simpler for you. That works as well. And this is very low cost. A DNS lookup can be kind of expensive, but the cost is very low. It doesn't compete with other things going on. Most browsers can do 10 or more DNS lookups in parallel. There's usually not a lot of contention. The bandwidth is a couple hundred bytes, total up and down. So it's a very low cost, low risk technique to deploy. In addition, on some browsers, they will open a TCP connection. They'll warm up a TCP connection, so you'll get even more benefit than getting the DNS lookup out of the way. And here's an example. I just happened to be looking at Airbnb last week, and I saw that they had 3 DNS prefetches in their page for their CDN. So how much time are you going to save? This is a stat from an article from the Chrome team when they first talked about this feature. And here, this was, across not a huge user set. This was a bunch of Google employees who were using this build before it got launched. And, but it was, hundreds of thousands of DNS lookups. And the median was 87 milliseconds. You can also look at this in your browser if you go to Chrome, histograms, DNS. You can see the DNS lookup times for yourself. So I pulled a screenshot from my Chrome last week, and I actually can't read that. I think it's like 67, 63 milliseconds. So, and on mobile it's going to be a lot worse. So it can be, especially if you have multiple domain names, it can be a fair amount of savings to reap by deploying this technique. Okay, so where is it supported? Unfortunately, we don't see a lot of browser support for this right now. It's in Chrome, and I'll mention these version numbers were just as far back as I could get test results for. So, for example, in Firefox, I talked to those guys, and they said they've had DNS prefetch and prefetch since 12 on, but I can't find a version of Firefox 12 to test on, which is good. Whew. So we have DNS prefetch in Chrome, Chrome Mobile, Firefox, Firefox Mobile, and it's coming in IE 11, right? So, it's not a long list of browsers, but it's a significant amount of traffic. So it could be worth looking at. The next one that's a little more aggressive we could look at is link-rel prefetch. Here the href is a full URL of a resource that you want to download and get out of the way. Now, normally I don't like reading specs. They're kind of lengthy, but the spec for this is pretty short. So I'm actually going to read it. Link type prefetch. The prefetch keyword may be used with link A and area elements. This keyword creates an external resource link. The prefetch keyword indicates that preemptively fetching and caching the specified resource is likely to be beneficial, as it is highly likely that the user will require this resource. There is no default type for resources given by the prefetch keyword. I don't know what that last sentence means. But I read this, and I'm left wondering a lot of things. I wish it had been, for a spec, I don't feel like it's very specific. Like, I would have liked it if they have specified maybe that the resource should be downloaded. It's not mentioned here, right? So I read this, and I'm like, is anything downloaded? How many things will it download? Will it do it immediately, or does it happen later in the page, after onload maybe? What's the priority against other downloads that are in the page? I want my stuff to get downloaded, but I don't want to screw the current page that I'm on. What happens when the user transitions to that next page? Whether it's the page I hope they're going to or some other page. And does it support HTTPS? So I did my usual thing. I created a browser scope user test. I tweeted about it. I also redirected to it from this awesome domain that I own, getting my $10 worth. So you could try it right now if you wanted to, especially on mobile devices. Would love to see more results. But I got about several hundred results across about 50 browsers, and that's the data that I'm using to report support in this talk today. So let's answer some of these questions. First of all, we can see that, again, prefetch, not a lot of support right now. Android 4 browser, the old Android browser, Chrome 31 Plus. And so it turns out we've actually had prefetch in Chrome, and it regressed. And so we've got to fix it. And if you use this pre-render flag, you'll get the fix in the latest version of Chrome. Nightly, Chrome Canary. It's in Firefox since 12 Plus, Firefox Mobile since 12 Plus, and it's in Opera. So how many prefetches, if you put them in your page, how many will get downloaded at any time in parallel? So Android will do 6 in parallel, but only 1 on the same domain. So if you're sharding, you might be able to get more downloaded, but otherwise it's going to be 1 at a time. And then we see in Firefox, they only do 1 period at a time. So if you do 3 of them, it's going to be 1, and then when it's done, the second one, and then when it's done, the third one. So I filed a bug for this, and I think they'll probably raise it up to 6 or 10. We see in Chrome and Opera, they'll do 10, and they'll do 6 on one domain. That's the kind of behavior we kind of expect with that 6 value. So there's a lot of variance there. No surprise, we're seeing browsers deal with this implementation very differently. When do the prefetches happen? Do they happen when they're seeing, or does it happen after onload? So we see that Android, Firefox, and Firefox Mobile all delay the prefetches until after onload. So I like the idea of making prefetches a lower priority, but waiting until after onload is pretty late. Because remember, I'm trying to get something downloaded now so that when the user goes to the next page, it's already in the cache, right, in memory. And so if it doesn't even start downloading until the current page is done, fires onload, that window of opportunity to get it downloaded is smaller, is reduced. So maybe I'd like it better if it was just given the lowest priority of all the downloads that are queued up for this current page. And we see that's what Chrome and Opera do. Well, or at least they don't delay the prefetch. So let's look at the priority. The lowest priority right now of a resource in these browsers is images. So I created a test where I compared the priority of this prefetch item to an IMG image in the page, and it turned out that they were equal. So we really do need the browsers to revisit their implementations and give these prefetches a lower priority than the resources on the current page. I thought this was the most puzzling result. What happens when you transition to the next page? So let's keep in mind, I put this prefetch in there so that when you go to the next page, it will already be downloaded. And yet, when you transition out of the current page to the next page, every browser cancels the request, right? This doesn't make sense to me, right? So especially if you look at how if you fire these after onload, that window of opportunity is going to be small. It would seem to me that it would be better for the browsers to keep these requests going, and maybe if they're very lengthy and the user transitions to the next page and the resource isn't used, then to cancel the downloads. But canceling the request, I don't think is the right thing to do here. So what are some tips if you want to do prefetch? Make sure that the resources are cacheable. What the prefetch is going to do is it's going to put it in the cache. The user is going to transition to the next page. If it's the page that you expect them to go to, that page is going to ask for the resource. If it goes to pull it out of the cache and it's expired, it's going to have to request it again. So you really want to focus your prefetch on resources that are cacheable. And you probably want to prioritize your prefetches, and that's going to be mostly JavaScript and CSS. It would make sense to prefetch HTML, but typically HTML isn't cacheable. So you would just have to request it again. So for prefetch, I think mostly JavaScript and CSS. And with this canceling the request behavior, some browsers do support an accept ranges header where they will resume the request from where they left off when they canceled it. So for those browsers, you could put a accept ranges bytes in your response header in your response, and then you might get some benefit there for whatever did get downloaded. I think what we'll see going forward, at least in Chrome, is that canceling behavior will get optimized. And this is the third of the three link rels that I wanted to talk about, link rel pre-render. So here you put the URL of the website that you hope that you think the user is going to go to next. And you can think about it as if this is being loaded in a separate tab. It's just a hidden tab. So that URL is being loaded. So the caching headers aren't really a factor. What's going to, I forgot to mention this. So I don't know if people have been paying attention to the background images. I should have been calling more of them out. When I tried to think of one that was appropriate for pre-render, the only thing I could think of was rendering lard. And I found Flickr images for rendering lard, and they weren't good background images. So then I got to the second bullet here about a hidden tab, and I thought, hidden tabby. There we go. That's what I'm talking about. So caching headers aren't such a factor because the page is being loaded. I love it. The page is being loaded in a background tab, and it's just going to be swapped in. It's not going to be reloaded, right? So even if there are resources in the page, like the HTML, that aren't cacheable, it doesn't matter because it's not going to be re-requested. The JavaScript in that page is going to be executed. Again, it's just like as if you opened, you command-clicked on a link and it's opening another tab. It's going to load. So all of that JavaScript is going to load. So if in that page you have JavaScript that's doing things like ads, analytics, starting a photo carousel, things like that, you should use the Page Visibility API It was created mostly for this scenario so that you can know that your page is loading, but it's not visible right now. And so those things like counting an impression shouldn't be done because no one can actually see this page right now. So this is a fairly costly pre-browsing technique to deploy, right? We're going to be downloading a lot of stuff. If you do this on mobile and people are on metered plans, you might download websites that are 500K, a meg, and people are going to have to pay for that, and they might not actually transition to the site. So you want to make sure to use this where you have very, very high confidence that the user is going to that next page. Okay, so, I just wanted to throw this up there. If you want to look at this, again, in Chrome, you can use the pre-render enabled flag, and you can go to Chrome Net Internals pre-render. And you can see here, I was doing this last night, and in search and on websites that I go to frequently, like spriteme.org, stevesouders.com, httparchive.org, when I type those into the Omnibox in Chrome, it recognizes that. It knows I've been there so frequently that even before I hit return, it will start pre-rendering that site. And when it's green, it means that it pre-rendered and it actually was used. So you can take a look and see how that behavior is working for you. And you might want to build up some history about that Omnibox recognition. Now, one thing is, I said before about this previous page situation. You really don't know what the user's next page is going to be. You don't really know what their intent is going to be. And so it's possible that you could have a lot of false positives here. But you could do something to reduce that, and that could be get more clues as to the user's intent. And one of the most obvious ones is a mouse down on an anchor in the page. When they do mouse down or touch start, you could say, oh, well, let me start prefetching stuff. Now, we're about to transition to the page, so this is going to have less of a benefit until we get browsers to fix that behavior where they cancel requests on transition. But certainly a DNS prefetch here would be very useful to do. So that's a way to still get the benefit, even after the user is given an indication of what might happen next. Pre-render only supported in Chrome, going to be supported in IE 11. So not a lot of support for these techniques right now. I think we're going to start seeing wider adoption. And I think the support right now is significant enough that developers should start thinking about deploying these. What about this transition phase? I think this is a huge window of opportunity. If we look at this process flowchart for the nav timing API, there's this period, this transition period between navigation start and when the first byte of the response comes down, where the developer does not have any foothold, right? The previous page is already unloaded, and the next page, not even a byte has come down. And so, basically browsers are there twiddling their thumbs. They're not doing anything. They're just snoozing. But that's wrong. They're not snoozing. What are they doing? They're doing DNS pre-resolve. How does this work? The browser can know what DNS resolutions it's going to need before the page has even been requested. This is true for start pages. Most browsers have this now, the 10 favorite sites. Here's an example in Chrome. You can bring up Chrome DNS, and it will show you the 10 DNSs it's going to pre-resolve when you start your browser. If you're typing a URL, like I type HTTP archive all the time, it could know, or I'm going to type a search term, it might resolve whatever my default search engine is. So in my browser, if I type H, it will pre-resolve the DNS for httparchive.org just by typing H, because I go there so frequently. It's an amazing website. You should check it out. When you load a page, a lot of browsers, Chrome, for example, will scan all the hrefs and sources. I don't know if Chrome scans like script sources and image sources. I know Firefox does. We'll scan those, and we'll pre-resolve the DNS lookups. If you do a on hover or mouse down over links, if maybe that link was created dynamically, so it wasn't scanned in the HTML markup, but the DNS could be So these are all ways that the main page DNS could be pre-resolved, but also the DNS for sub-resources could be pre-resolved. In Chrome, again, if you look at Chrome DNS, we show for an individual website what subdomains are most likely have been seen before, and we can give weights to those, and the browser will actually start pre-resolving some of these DNS for DNS lookups for subdomains as you're transitioning to that page. So again, to have that DNS lookup done before it's actually needed. And in addition, for these high confidence domains that you might navigate to, the browser will potentially open up a TCP connection. And you can see that here, again, in Chrome predictors. Yellow will just be a DNS lookup. Green, if you actually do that transition, will do a TCP preconnect as well. So you can get some visibility into how frequently that's happening for your browsing behavior. And again, you can look in this same chart, and under sub-resource preconnects, you can see which of these domains actually had preconnects fired up. So this is one I want to talk about. Prefresh, this is an idea that Tony Gentlecorn and I came up with about a year ago. I didn't make this word up, though. I forget what I called it. This is from Michael Klaber, a guy at Google, so we'll put a TM up there as well. And of course, I'm joking about that. I don't even know what legally TM means and how binding it is or anything. So the idea here is kind of like the DNS stuff. Let's not just remember every domain that you used when you went to a page. Let's remember every actual resource URL that you used when you went to a page. And if I go to that page again, depending on how frequently those sub-resources were used, I'm actually going to start preloading those sub-resources. So this is really important. As that HTML document is downloading, I'm also downloading the version of jQuery that might be needed, the site's main CSS file, so that when the HTML does arrive, all of those resources are already in memory and ready to be plugged into the page. In Chrome, you can turn this on in Canary today with this flag. And so you can look at Chrome predictors, and you can see in this other tab, resource, prefetch predictor. You can see what sub-resources are associated with a given URL and what the score, I think the highest score is 200, what the score is for the prioritization of how that might be prefreshed. So then, if you go to the current page, we have the preloader working. So this is something that's done by the browser, but it's important for developers to understand how it works, because how you build your page could work well or not so well with the preloader. Probably the most, I wanted to mention, this is the biggest performance improvement made to browsers ever, bigger than anything else. And that's because before we had preloading, when you would download multiple scripts, the parser would stop when it hit a script, an external script source, and it would stop all parsing until that script was downloaded. So if you had 3 scripts in a row, the script would stop the parser, it would get downloaded, executed, the next script would go, the next script would go. Today we have an average of 8 to about 10 scripts per page. Imagine if all of those were downloaded sequentially. Pages would be so slow. So that's the way it used to be, but then about 4 years ago we started seeing this preloading behavior, and the browsers would have, the HTML parser would be blocked when it hit that script source, but it would have a speculative or look-ahead parser that would look further ahead for script, IMG, iframe, link, for other downloads, and would start those downloading in parallel. So this preloader is a huge, huge, huge performance improvement for browsers. I think a test was run recently on Chrome that it alone, just this one feature, makes websites 20% faster. But there's lots of new logic in it. Generally, this logic is load scripts and style sheets early, load images later. But the way that that gets implemented can have a lot of impact and impact different pages differently. So what are some of the surprises there? I always like spelling surprise incorrectly. In fact, I've added this to my dictionary. I think this is the way surprise should be spelled. Because prize with a Z, it's more fun, and surprises should be fun. So join me. From now on, spell surprise with a Z. So what are some surprises? I think the most like the most popular one is with responsive images, where you're loading images at the correct size via JavaScript. So you're not using the IMG tag, so the look-ahead parser is not going to see these images, so they're not going to get loaded early. And so if you do have some IMG images, those will get queued up to be downloaded earlier than your JavaScript images. And typically the JavaScript images, the responsive images, are more important on the page. So if your IMG images are less important, but they get queued up for download first, that's not going to make your page render in an optimal way. It's good if you're using responsive images to do sharding. And that way, at least, if these IMG images got queued up, they would be on domain 1, and your JavaScript images would be on a separate domain. So at least they wouldn't be below these IMG images that might be a lower priority. But this is another one that I see happening a lot that I want to talk about. Is I wrote this rule in 2007 to put scripts at the bottom, and that's generally a good thing. Back then, browsers worked the way I described, where everything above them would be downloaded early. But now, these scripts at the bottom are seen by the look-ahead parser, and they get downloaded higher up in the page. And so the developer put them at the bottom intentionally, saying, I don't think these are that important. It's okay with me if you download them last, after everything else. But now they've been promoted in the download order, because generally scripts have a higher priority. And so they might steal connections from other resources that are more important, especially images, because images, as I mentioned before, have the lowest download priority, lower than scripts and style sheets. So a good example of this is, can everyone read the 14th line there? Is Airbnb. So you don't need to read the code. Just the highlighted blue part is the main image. I mean, look at the website. The front page of the website, what is it? It's one big image. And that blue part is where that image is in the HTML. And then down at the bottom, they have all these script sources. So they've followed that rule from 2007. They put their scripts at the bottom. But then if we look at the download order, those scripts at the bottom got promoted up. And this green bar that I highlighted in the waterfall chart, that is that big image that really dictates the design, the user experience of the page. And we can see how it got demoted really low. And if you look at the web page test film strip view, the image didn't get rendered until about 4.5 seconds. That's really low. So this is Chrome, right? So I'm kind of complaining about Chrome. I don't mind doing that when Chrome isn't working well, but I was very excited when I went to capture this screenshot last week and I couldn't reproduce it. So this, I had to go back, was from an earlier slide deck I did about 6 months ago. And sure enough, 6 months ago, this is how Chrome behaved. Since then, the Chrome team, I think James Simonson, have tweaked that logic. I mentioned that this is all new logic in the preloader. He's tweaked that logic to allow images to creep in. I think it's only 1 or 2 images are allowed to load earlier. But because of that change in the logic, for this site anyway, when I went to capture the screenshot last week, that big image has been allowed to creep in. And instead of 4 seconds, we're getting this big image rendering at about 1.5 seconds. So this is really, really cool. Okay, so if you're like me and you want to take slow things and make them fast, I think this is a place we need to look going forward, especially if we want to compete with native applications. And so as developers, we should think about link-rel DNS prefetch, pre-render. Anyone here who works on a browser or talks to browser vendors, make sure to continue to work on DNS pre-resolution, TCP pre-connect. Prefresh is a new idea. All the code is out there in the Chromium project. And as developers and browser developers, we need to work together on the preloader and understand how that works. Oh, and I wanted to mention, I started working on this and I was gathering a lot of scattered information, and then Ilya's book came out, and definitely more than half of what I covered here is in his book. So if you didn't go to his tutorial yesterday, I think he'll be signing books sometime today or tomorrow. Definitely get a copy of his new high-performance browser networking book and check it out. Thank you very much. Wow, I finished on time, and as the co-chair, I am going to allow myself 3 minutes for questions. Yes? The question was, do any of these pre-techniques send a header that let the browser know that you're, it's one of these proactive techniques? And no, as far as I know, they don't. And I've been looking at this stuff a lot. I think I would have seen it. So no, I don't think they do. That's an interesting idea, though. Any other questions? Yeah. So the question was, what if I pre-render a page and it has a pre-render in it? I don't know. That's a really interesting test. I would bet that it's not honored until the visibility flag goes on. And the question was, can I pre-render my competitor's website? Well, remember, pre-render is in a current page. And so, oh, yeah, you could pre-render any URL that you want. Yeah. Yeah, you can screw up their metrics, but you can do that with an iframe as well. So, yeah, there's the ability to do that. And last question, yeah.
Does a pre-render or prefetch take into account if it's already in cache? Like, so on a prefetch, you already have the JavaScript file in memory in cache. Does it still request it?
Yeah, the question was, do prefetch and pre-render honor the cache? Yeah, they do. So especially for prefetch, that's why I said you only want to prefetch resources that are cacheable. But yeah, if it's in the cache, then the prefetch doesn't have to fire. Yeah, won't have to do anything. Okay, so if you have any other questions, come on up. I think I'm signing books in about 10 minutes, and thanks for coming.